The year is 2017, a time of rapid technological advancement where the boundaries of what's possible are constantly being pushed. On a test range in Dahlgren, Virginia, a new kind of cannon points toward the horizon, poised to change the future of naval warfare. This isn't your grandfather's naval gun. Unlike traditional naval guns, this weapon has no brass shell casings, no powder, no conventional explosives. Instead, it hums with potential energy, emitting a low electric hum as it charges. Suddenly, with a sharp electrical crack, a surge of power unlike anything seen before, a projectile launches, blazing downrange at incredible speed, faster than anything previously imagined. This is the U.S. Navy's electromagnetic railgun, a marvel of engineering, a weapon that could redefine naval warfare, changing the balance of power on the open seas. Years of research and hundreds of millions in investment, a testament to the Navy's commitment to innovation, led to this moment. A moment of truth, a culmination of years of hard work and dedication. The railgun's promise? What does this revolutionary weapon offer? To fire projectiles farther, extending the reach of naval power, faster, delivering devastating force with unparalleled speed, and more cheaply than any gun before. A cost-effective solution for modern naval warfare. Instead of gunpowder, it uses pure electromagnetic force, harnessing the power of electricity, lightning in a barrel. A controlled burst of energy unleashed with devastating effect. A single destroyer could carry hundreds, transforming its offensive capabilities of these low-cost, high-impact rounds, ready to be deployed at a moment's notice, striking targets over 100 miles away. A reach that extends far beyond conventional weaponry. The railgun's hyper-velocity projectiles traveling at over Mach 7, a speed that redefines projectile warfare, could intercept missiles, providing a crucial layer of defense, or devastate targets ashore, offering unparalleled fire support for ground operations. No explosives needed, just kinetic energy, the sheer force of motion, making each shot safer and more reliable, reducing the risk of accidental detonation and ensuring consistent performance. The Navy wasn't just building a bigger gun, it was embarking on a new era of naval technology. It was rewriting the rules of sea combat, a paradigm shift in how naval battles are fought and won. Early tests captured imaginations worldwide, showcasing the potential of this revolutionary weapon, showing a simple metal slug tearing through steel, demonstrating its immense power, with raw power, a force to be reckoned with on the modern battlefield. The railgun became a symbol of technological ambition, a beacon of innovation in the world of military technology, a new kind of arms race powered by electricity, not gunpowder, a race to harness the power of electromagnetism. This was the dawn of a new era in naval firepower, a future where the seas are dominated by electromagnetic weaponry. At its core, a railgun is simple in concept but a marvel of engineering. It abandons gunpowder using electromagnetism instead. Two parallel rails form a circuit. A projectile bridges them, completing the path. Massive banks of capacitors store energy, then unleash millions of amperes in a split second. This current creates a powerful magnetic field, generating the Lorentz force that hurls the projectile forward. Unlike traditional guns, the railgun accelerates its projectile along the entire barrel, reaching speeds over Mach 7. The result, a slug of metal with enough kinetic energy to obliterate targets, no explosives required. But managing this energy is a challenge. Each shot generates extreme heat, threatening to melt the rails. Advanced materials and precise power management are essential for repeated firing. The railgun is more than a gun. It's a fusion of power generation, material science, and high-speed engineering. Let's compare the capabilities of the electromagnetic railgun to the Navy's standard 5-inch gun, a mainstay of naval fleets for decades. When we examine the differences, the advantages of the railgun become dramatic and immediately apparent. The traditional 5-inch gun fires projectiles at approximately Mach 2.5, achieving a range of about 13 nautical miles. The railgun, on the other hand, propels its projectiles at speeds exceeding Mach 7. This allows for an extended range reaching well beyond 100 miles, drastically increasing the battle space. This significant leap in range means ships equipped with railguns can strike targets from far outside the reach of many enemy defenses. Beyond speed and range, ammunition represents another revolution in naval warfare. Conventional shells are packed with explosives, making them inherently risky to store and handle within the confines of a ship. In contrast, railgun rounds are essentially inert metal slugs, far safer to store and also more compact, maximizing space. Of course, cost is always a significant consideration. Railgun projectiles offer a considerable cost advantage, being far cheaper to produce than sophisticated missiles. This lower cost allows ships to carry a significantly larger number of rounds, potentially hundreds instead of just a few dozen missiles. The sheer kinetic energy delivered by a railgun round upon impact is truly devastating. This immense energy means no explosives are needed to effectively punch through even heavily reinforced armor or hardened bunkers. Furthermore, with its potential for a high rate of fire, a railgun-equipped ship could unleash sustained barrages of projectiles, overwhelming enemy defenses. This capability has the potential to fundamentally change established naval tactics and strategies. This powerful combination of speed, extended range, enhanced safety, and a high volume of fire provides naval commanders with a whole new spectrum of strategic and tactical options on the battlefield. The railgun represents far more than just a simple upgrade to existing naval artillery systems. Instead, it signifies a true paradigm shift, a revolutionary leap forward in the realm of naval artillery. It promises a future where naval ships are not only safer for their crews, but also deadlier and far more flexible in their operational capabilities than ever before envisioned. The Navy's massive investment in the railgun was a strategic response to new threats. Adversaries developed anti-access strategies, long-range missiles and air defenses designed to keep U.S. ships at bay. The railgun offered a way to strike deep into these no-go zones from a safe distance. It could support amphibious landings, suppress enemy defenses, and provide a cost-effective alternative to expensive missiles. A single Tomahawk costs $2 million, a railgun round about $25,000. This deep magazine meant ships could fire hundreds of rounds without breaking the bank. The railgun's speed also hinted at a new defensive role, intercepting incoming missiles, even hypersonic threats. Its multi-mission potential, strike, support, and defense, made it a compelling bet for the Navy's future. The railgun was more than a weapon. It was a strategic tool for 21st century naval warfare. Turning the railgun, a concept once confined to science fiction, from theory to reality, required immense dedication and resources. The journey began in laboratories, fueled by the promise of a revolutionary weapon. It required years of rigorous testing at Dahlgren, Virginia, a Navy testing facility known for pushing the boundaries of naval technology. In 2008, the Navy achieved a significant milestone, firing a prototype at 10 megajoules. This was a crucial step, demonstrating the raw power the railgun could potentially unleash. It was concrete proof that electromagnetic launch was not just a theoretical possibility, but a tangible reality. The success ignited further research and development efforts. The next ambitious goal was to reach 32 megajoules, enough to hit targets at extended ranges, over 100 nautical miles away, transforming naval engagement strategies. By 2012, a full-scale prototype successfully met this mark, showcasing the advancements made in energy capacity and projectile velocity. It was now capable of firing glowing projectiles with immense force, demonstrating the sheer kinetic energy that could be delivered to distant targets. From this research, the hypervelocity projectile, HVP, emerged. A dart-like projectile engineered to not only survive the extreme acceleration of launch, but also fly with pinpoint precision towards its intended target. Navy engineers soon realized the HVP's potential extended beyond the railgun, as it could also be fired from existing Navy guns, significantly extending their range and destructive power, offering a cost-effective upgrade to existing naval assets. By 2017, the railgun system had undergone extensive testing, firing hundreds of shots, consistently punching through thick steel targets, conclusively proving its immense destructive potential and validating the design principles behind the electromagnetic weapon. With successful land-based trials completed, plans were initiated for at-sea testing, with the ultimate goal of moving the railgun technology from the controlled environment of the lab to the unpredictable and demanding conditions of real-world naval operations. The HVP's versatility and adaptability meant the Navy's significant investment in the railgun program had already paid off, even as the railgun system itself faced technical challenges and subsequent delays in its deployment timeline. Despite the setbacks, the program stood on the brink of fundamentally transforming naval firepower and shaping the future of maritime warfare. Navy leaders hailed the railgun as a disruptive leap in naval warfare, Rear Admiral Matthew Clunder called it one of the most disruptive capabilities ever pursued, emphasizing its safety and cost-effectiveness. Official statements highlighted the deep magazine and multi-mission potential, persistent, precise, and lethal. But not everyone was convinced. Experts like Brian Clark noted the immense power demands, limiting deployment to only the newest ships. Retrofitting older vessels would be costly and complex. As the hypervelocity projectile proved effective in existing guns, focus shifted from the railgun launcher to the HVP itself. The HVP could triple the range of standard destroyer guns, offering an immediate upgrade fleet-wide. The narrative evolved. The real breakthrough was the projectile, not the gun. Despite progress, the railgun faced daunting challenges. Barrel erosion limited lifespan. Early prototypes could only fire a few rounds before repairs. The power demands were immense. Only the newest ships could handle them, and fleet-wide upgrades were impractical. Meanwhile, the HVP offered a faster, cheaper way to boost firepower using existing guns. As hypersonic threats emerged, the Pentagon shifted focus to defensive interceptors and hypersonic weapons. By 2021, funding for the railgun launcher was cut, with resources redirected to the HVP and other priorities. The railgun's legacy is the revolutionary projectile it inspired, a lesson in how innovation can yield unexpected, game-changing results. Sometimes the journey matters more than the original destination.